Unit 1, Lesson 10, Applications with Linear Systems. Example 1. A baker sells plain cakes for $7 and decorated cakes for $11. On a busy Saturday, the baker started with 120 cakes and sold all but 3. Her takings for the day were $991. How many plain cakes did she sell that day, and how many were decorated before they were sold? So here's an example of a word problem, an application type problem. You're not just given the equations directly, you have to create the linear system yourself based on the information given in the problem. So let's define our variables. So you can see here there's a distinction between selling plain cakes and decorated cakes. So let's define P to be the variable that tells us the number of plain cakes. And I'm going to define D to be the variable that tells us the number of decorated cakes. Okay, so in my first equation, I'm going to talk about the number of total cakes that were sold, because we're told that she sold, or this baker sold all but 3, so 120 cakes, but except for 3 of them. So what did she sell? She sold 117 cakes. So my first equation is going to be the number of plain cakes plus the number of decorated cakes equals a total number of 117. Okay. The second equation is going to come from the fact that she earned $991 for that day. So the second equation has to be about the amounts earned, or money taken in. So if she sells $7, if she sells plain cakes for $7, I can express that by saying 7 times P. So $7 times the number of plain cakes she sold equals the money she made for selling plain cakes. And she sold decorated cakes for $11. So you can see that right here in the question. So $7 and $11. So for the decorated cakes, it's $11 per cake times the number of decorated cakes gives you the total amount of money that she made from selling decorated cakes. And in total, that adding plain cakes and decorated cakes gives you $991. So there are my two equations. So what I'm going to do is rearrange. So let's solve this system. It's a linear system. So instead of P and D, like instead of X and Y, you're doing P and D, so that's fine too. So what I'm going to do is rearrange by using substitution. So rearrange 1 and substitute into 2. So rearrange equation 1 and substitute into 2. Okay, so let's take equation 1. And equation 1, I'm going to isolate. Let's pick P. So P is equal to, if I subtract D on both sides, so 117 minus D. Okay, and so in equation number 2, I'll write 7 times P, and P will be substituted with 117 minus D. And then I have plus 11D equals 991. So now you can see I've eliminated the variable P, and all I'm left with is D. So that's good. Now I'm going to solve for D. So when I solve for D, I'm going to kind of expand this a little bit. So 7 times 117 is 819 minus 7D plus 11D equals 991. Okay, and then I'm going to collect some like terms here. And when I collect like terms, 7D and 11D, so negative 7 plus 11 is 4D equals 991. If I subtract 819 on both sides, I'll have minus 819 here on the right. Okay, and then I'm going to simplify the right side a little bit. So 4D equals, so subtracting these two numbers, I get 172. And then if I divide both sides by 4, I'll get my answer for D. So D is equal to 172 divided by 4, which is 43. Okay, so there it is. There's my D value. That's the number of decorated cakes sold. So to find the number of plain cakes sold, I'm going to substitute. Oh, what happened to my drawing tool? Okay, substitute D equals 43 into one of the equations. I'll pick equation 1. Looks because equation 1 is much simpler than equation 2. So I'm going to say P plus 43. So remember, D plus P plus D is equal to 117. Okay, and if I subtract 43 from both sides, I'd have 117 minus 43, which is equal to 74. So I have 74 plain cakes sold. Okay, so therefore, I'm going to say here, she sold 74 plain and 43 decorated cakes. Okay, there we go. So let's look at example number 2. Raymond invests his summer earnings of $3,050. He invests part of the money at 8% per year and the rest at 7.5% per year. After 1 year, these investments earned $242 in simple interest. How much did how much did he invest at each rate? So when you have percentages, we can't do our linear systems with percentages. It's often a good practice to always switch the percentage to decimal. So 8% is going to become 0.08, and 7.5% is 0.075. Now, how do I always convert a percentage to a decimal? You may remember from grade 9 math. We convert a percentage to a decimal by dividing by 100 or moving the decimal place two numbers to the left. Okay, so let's define our variables. Let's say X is the amount invested at 8%, and we'll say Y is the amount invested at 7.5%. Okay, how do I know how to make these variables? Well, the question only talks about investing money, so you need to know how much money you're investing. And so how do you differentiate the types of money you're investing? Well, one type of money is invested 8%, the other type of money is invested at 7.5%. Okay, and the question even asks how much did he invest. So ultimately, you're looking for how much money is being invested at each rate. So there you go. The question is really the big clue that tells you how to what to look for, what's variable, how to make your variables. Oh. Something is. Let me see. Can I still write? Oh, I can still write. Okay. I can't erase. Why can't I erase? Oh, okay. So maybe a little bug. Okay, let me see if I can. Let's continue on. Okay. So let's define our two equations. So equation number 1. Oh. Oh, something happened. Let's see if I can fix this real quick. Okay, there we go. Okay, so equation number 1 is the total amount of money, like he's investing. So the amount of money invested 8% plus the amount of money invested 7.5% equals a total amount of $3,000 and $3,050. Okay. Equation number 2 involves the percentages. So 8% of X plus 7.5% of Y gives you the amount of interest that he earned So you earn $242 of interest. Here are the two equations. So now now you can look at equation number one, much simpler. There's no decimals, okay? Equation two is a little bit more messy. So when I do substitution, I'm going to isolate equation number one first, okay? So according to equation number one, if I isolate, let's pick x. So I'm going to say x equals 3050 minus y, okay? And I'm going to substitute that into equation number two. So equation number two, I'm going to have 0.08x, and x is going to be replaced with 3050 minus y, plus 0.075y equals 242. It's always a good idea to put your substituted variables in brackets, of course, because there are two terms here. You're going to be expanding, so you have to be multiplying those two. Okay, so 0.08 times 3050 is 244 minus 0.08y plus 0.075y equals 242. Okay, and then if I subtract 242 from both sides and I collect these two like terms, so I'm going to collect these two, I'm going to get some negative value here, so negative 0.00205 y equals 242 minus 244, subtract 244 from both sides, and then I have to simplify that a little bit, so negative 0.005y equals negative 2, and if I divide both sides by negative 0.05, I'll get my answer for y. So these two cancel out, and so y equals, so negative 2 divided by negative 0.005 is 400, big number, okay? That's what happens when you divide by decimal. You get a bigger number than the numerator. All right, so what's x? So, well, if I use equation number one, x is equal to 3050 minus 400, and so x is equal to 2650. So Raymond invested $400 at 7.5% and $2,650 at 8%. And that's the answer. And don't forget, check your work. Always check your work with the checking step. Example number 3, a canoeist took 2 hours to travel 12 kilometers down a river. The return trip against the current took 3 hours. What was the average paddling rate of the canoeist? What was the speed of the current? Okay, a little bit more like a physics problem. So let's try and draw a little scenario. So I'm going to have a river, and here, okay, there's my river, and let's say the current is going this way. So that's my current. Okay, and so if you are swimming upstream, you're going this way. You're going against the current. Downstream means you're going with the current. So obviously, if you're going with the current, you're going to travel the same distance faster than you would be going against the current, right? Because the current is pushing you back. All right. So then the speed is the average between going with the current and then going against the current. Okay. So let's write this down. So a little star here. So going, little kind of science lesson for you here, a physics lesson. So going downstream the current makes the canoeist go faster because the current is helping you, pushing you along. Okay. However, when you go upstream, so going upstream, against the current, slows the canoeist down. Okay. Now another little physics thing. Well, what is the distance, or what's the speed? So speed If you think of like, your car speedometer, it's kilometers per hour. It's like a distance per time, a unit of time, the unit of distance per time. So you can think of speed as a formula of distance divided by time. Okay, and so we need to have that kind of formula to help us with this. All right, let's define our variables. Let's say, what can we see? What is the average paddling rate? So I need to find paddling rate. Let's call this P. And what is the speed of the current? So I need to find the speed of the current. Let's call that C. Okay, so when we are going downstream, so two scenarios. You have two different speeds going downstream and upstream. So it's going to be, I'm going to start off with that. So if you're going to go down the stream, the current is helping you. So well, what kind of formula can I create? I can create a formula with distance. So I need a little bit of a distance formula. So maybe I will rearrange this formula here. So if I want a distance, I would multiply both sides of my equation by time. So I could say here, speed times time equals distance. Okay. All right. So if I can use that idea, then I can sort of figure out something else. So if I have downstream, what's the scenario downstream? Well, you have a paddling speed, so your paddling rate is like a paddling speed. So P plus you have the speed of the current helping you, C, equals the total amount of, well, what's the speed going down? Well, if it takes you 12 kilometers to go down the river, and you divide that by 2 hours, because your speed is, it takes you 12 kilometers to travel 2 hours, so that's a speed of 6 kilometers per hour. So the speed that you're paddling plus your speed of the current is together combined, giving you a total speed of your boat of 6 kilometers per hour. Okay, so that's going to be equation number 1. Now let's try and figure out the upstream, because upstream is a little bit different. So you have your paddling speed. Now the current is against you, so you have to subtract it from your paddling speed. So now your boat's going a little bit slower. And that's going to equal 12 kilometers. You have to travel back 12 kilometers, but instead of taking you 2 hours, it takes you a bit longer because of the upstream current. So it's takes you 3 hours instead of 2. So 12 kilometers done over 3 hours is a speed of 4 kilometers per hour. So your paddling speed minus the current speed is equal to 4. And so there's equation number 2. Okay, so let's put these two equations together. I'm going to use elimination this time. So P plus C equals 6, and P minus C equals 4. So you stack your equations, line up the variables. Okay, so if I chose to subtract both equations, so P minus P is 0, C minus, so let's see, C minus negative C is C plus C, which that's 2C, okay, equals 6 minus 4 is 2. So 2C equals 2, and then if I solve for C, 2 divided by 2 is 1. So C equals 1. The current speed is 1 kilometer per hour. Okay, now if I substitute C into, let's say, equation 1, so P plus C equals 6, and then P plus 1 equals 6, so P equals 5. Okay, so there's my paddling speed. I'm paddling at a speed of 5 kilometers per hour. And that's my solution. So therefore, the canoeist paddled 5 kilometers per hour, and the current moves 1 kilometer per hour. Okay, so that kind of makes sense, right? So if you look at, well, if I paddle at 5 kilometers and the current helps me at 1 kilometer, then I can get a total speed of 6. But if I'm going against the current, well, I'm paddling at 5 kilometers, so that's the strength that I can paddle at. And the current is slowing me down, so I subtract 1 kilometer per hour for a total of 4 kilometers per hour as my speed. So I go slower as I go back upstream. Okay, so those are just some examples in my video here, and I want you to try a few of your own. So that ends this video.